Hey guys, here's a little project that is just simply designed to practice using the Pythagorean theorem and finding the length of a hypotenuse using the distance formula and 2 points, and you get to choose everything that's going to happen here. And what you do is you're just going to pick one point, choose another, work from there, and then work your way around the working space. So I'm just going to start over here. I'm just going to start, I'm going to put a point over, and then I'm going to choose a point here. Okay. Now what we want to do is obviously there's an xy that goes with this, and then another xy that goes with this. All right. At this point, what we're going to use, the idea that we want to know how far it is between these 2 points, and I drew my line a little farther, but it's no big deal. And now what I need to know is what is x and y. I have a second piece of paper here, and this is going to be my x sub 1, y sub 1, and x sub 2, y sub 2, since that's on this point is on my left and this point is on my right. So this is going to be 1, x sub 1, x sub 2, and then my distance formula looks like this. The distance is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub squared. Now, my x sub 1, y sub is negative 15, 16, negative 19, and my y is 10. Excuse me, this is the point I'm looking at. Y is 14. So 14, it's important to keep track of this, right? So here's my x sub 2. X sub 2 is negative 15, 10. Y sub 2 is 10. So the number I'm going to put in here, I'm looking at distance, got that whole thing in my projection, right? So the distance equals, I'm going to have my square root right here, and then inside x sub 2 is negative 15 minus a negative 19, and that's going to be squared, and then added to y sub 2 and minus a positive 14. And that is also going to be all right. So so what this is, we need to take what we have and simplify. Nobody can do this all at once. All right. So what we're going to do is that. Let's simplify this before I do it. Negative and a negative. So a subtraction of a negative is really a positive. So I'm going to just turn that into plus 19 right here. And then this is now the distance equals the square root, and we're going to simplify what's in there. Negative 15 plus 19 is a positive 4. 4 squared plus 10 minus 14 is negative 4. And we're going to square. And here, distance square 4 squared is 16 plus negative 4 squared is also 16. So this ends up being the square root of 32. 32 is not a perfect square, so into this, 32 is not a perfect square, so what I need is 32. Turn it sideways and it becomes a scientific calculator, and I'm just going to hit the square root button. And man, that is an irrational number. It doesn't quit, never terminates, and it does not repeat. Therefore, if I'm going to write it down at all, use an estimate of that number. And let's just go with hundredths today. So I'm going to take hundredths here, so I'm going to look at the spot where the 5 is. I'm going to take that 6 is greater than 5, so the 5 becomes a 6. It's going to be 5.66, and this becomes approximately equal to 5.66. I'm going to mark that on my picture over here, 5.66. Okay. What I'm also going to do is this. I'm going to draw a right triangle down this direction, line, and straight across this blue line. And if we look at this, what we have is a right triangle. Here's my square marking there. And I'm going to color it. I'm going to color it, let's go with green. Okay? I'm going to color this one green. I'm using my little colored pencils for stuff. If we look at this, right here what we ended up with in this problem was, if we look at the sides of this triangle, we have 4 here and 4 here. Now my second point, what I'm going to do is I'm just going to pick a point down here, right here, and I'm going to draw this line. Now for my second one, what I'm going to do is, instead of my distance formula, I'm going to draw that line down, make my right triangle, and here we are. Now I know how far this, what that line is there. I'm going to put an approximately equal. So I want to know what that's equal to. Well, on this one, what I'm going to do is I'm going to use, instead of my distance formula this time, I'm going to use a squared plus b squared equals c squared. Okay? So if I knew how far, I can just plug them in there and square them and find square root. So a is going to be 2, and b is 1, 2, 3, 4, 5, 6, 7, 8. B is 8. So I'm looking for c here, and this is a right triangle because I drew the right triangle. So a is 2, that, plus 8 squared equals c squared. Well, 2 squared, because this is just about, just like this up here, this is just about doing what you're substituting, and then simplifying, find your answer. So that's what we're going to do over here. 2 squared is 4 plus 8 is 64, which is still c squared. Now most people will say 64 plus 4, well that's 68. Well, you can put 68 over here, and 68 is going to equal 68. Wow, that's true. But you still don't know the length of the side over here because you eliminate your variable. You got rid of your variable. And you can't get rid of your variable if you're trying to solve for your variable. So let's just keep this. So here this is going to be 68 equals, well, how do you solve the sides? Well, there you go. Square root of c squared e, and the square root of 68. 68 is not a perfect square, so it's going to be an irrational number. And 68, again, 8.2462. So let's round again to the hundredths. So this is going to be 8.25. And again, it's going to be equal to 8.25. And I'm going to put that over here as well. Approximately equal to 8.25. Let's pick a different color. There we go. Orangish red or something like that. Oh, look at those, my colored pencils are so fancy they don't even tell you what color they are. Alrighty, there I'm going to do. I'm going to choose from here. Let's just choose one right over here. Alright. And I'm going to continue to do this. Sub 1 over here, and here's my x sub 2. So this is what I want you to do. I want you to do your first one this, your second one using the Pythagorean theorem, your third one right here is going to use the again, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. This, the square root of this is going to be now the reason I want you to do this, use the distance formula for the first one, for the second one, distance formula for the third one, and then the fourth one's going to be the Pythagorean theorem again. So the point of this is to show you and get you used to the idea that the distance formula and the Pythagorean theorem are related to each other. In fact, they're the same thing. A squared plus b squared is x sub 2 minus 1 squared and y sub 2 minus 1 minus, a squared plus b squared is x sub 2 minus y sub 2 minus y sub 1 squared. This is a, and this is b squared. It just doesn't look disguised. So this is what the assignment is. You do one with the distance formula, do one with the Pythagorean theorem, do one with the distance formula, you do another one with the Pythagorean theorem. And you go through, and I want you to do this at least 10 times. Okay? 10 times. 5 with the distance formula, 5 with the Pythagorean theorem. There you go. 5 of these, 5 of these. Now, this is what it might look like when you're done. You can keep going around. The next one might be down here, then over here, then over here, then up, whatever you need to do. Here are some examples. Example of one that young lady, and the class really just liked doing these, and so I just gave it to them extra credit. Here's another one. It's just started with one color and went kind of rainbow all the way around, but that's all they did. Okay, it's just choose a point, make a right triangle, figure out what the length is, choose another point, make your right triangle, figure out the length of your hypotenuse, pick another point, draw your triangle, calculate the length of your hypotenuse. Okay? And then at the end, what we want to do is we want to total all the length hypotenuse. Okay? So that's it. Distance formula and Pythagorean theorem. This is also going to help you out with the second assignment week. All right? We're going to have on Tuesday and Thursday we have meetings this week at 10 o'clock on Zoom. All right? Thank you much.